Hey guys, what's up? So in this video, I'll be talking about the problem C, make it permutation. So the problem statement is saying that you are given an array of length n and you have to make it permutation. And the definition of permutation is that every number should be distinct and the range of numbers should be 1 to n. Okay, so and we have to perform two type of operations. We can either remove integer from array A, and the cost of removing an integer from array A is C. Or we can insert any arbitrary positive integer x to any position, and the cost of inserting a number is D. So by performing these two type of operations, we have to make the array permutation. Fine. So let's understand by the help of any example. Like here we are given 1 2 3 6. So there are two ways of making it permutation. Either I can delete 6, so this is a permutation of length 3, or what I can do 1 2 3 and 6. So what I can do that I can insert here 4 and 5. So this is also making a permutation of length 6. Fine. And we can also do one thing, 1 2 3 and 6. What we can do that we can insert 4 and we can delete 6. So this is also making a permutation. So out of all these operations, we have to return the one which will cost us the minimum. Fine. So this problem is basically a greedy problem. So what we have to do that, let's understand by the help of the test case. Let's take the second test case, 5 1 5. So yeah, this is the test case which we have been given. So this is the array which we have been given, and this is the cost of removal, and this is the cost of insertion, if I'm right. So C and D. Okay, the first one is the cost of removal. Fine. So this is the cost of removal and this is the cost of insertion, and we have to make this array permutation by either inserting some numbers between these numbers, or we can remove some numbers from this. So let's see how we can approach this problem. Like we are given 1 2 3 5 and 6. So finally what we need is, we want a permutation like 1 2 3 4 5 and 6. Fine. So if we make a permutation of length 6, this will look like this. Fine. So our first number should be 1, second number should be 2, then third should be 3. So we'll maintain a current variable which will tell us that what should be the current number on which we are standing on. Fine. So we'll start from the first index, and this number should be 1, should be equals to current. Current is initially 1. So our first number should be 1. So this is 1 actually. So we don't have to perform any insertion operation here. And for this, what will the cost if we delete all the numbers on the right hand side of the 1? This will cost us 3 into D. So what is the value of D here? D is 5. So let me write it here, 1 and 5. So the cost of removal is 1 here. Fine. So for the 1, the insertion cost is nothing and the removal cost is 4 times 1. Fine. So for this index, our answer will be 4. Let me write it with another pen, which will be blue. Fine. Yeah. So for the first number, the insertion cost is 0 because our first number is 1 indeed, and the removal cost is 4 times 1. So for this index, our total cost will be 4. Let's move on to the second index. So if we move to the second index, what should be this current number in our permutation? So this will be 2. So we will increment our current by 1. So this will be 2. So this number should be 2, and it is actually 2. So nothing to be inserted on the left hand side, and we have to remove all the elements on the right hand side of this number. Fine. So the cost of removal is 3 times 1. So this will cost us 3. And then we'll move to the next index. Fine. Then here, and after moving, before moving we will increment our current variable. So this number should be 3 in our permutation, and it is 3. So nothing to be inserted on the right, and the cost of removal of all the elements on the right hand side is 2 times 1. So it is 2. Fine. Now we will increment our current variable because we want our next element in our permutation to be 4. So here 4 should be there in the fourth index, but it is 5. So how many numbers we have to insert is it will be achieved by the current number minus the index on which we are currently standing on. So 5 minus 4 should be 1. So the insertion will be, cost will be 1 times d. The value of d here is 5, 1 times 5. So as you can see that we have to insert 4 in order to get the permutation of length 5 here. So the cost of insertion is 5 and the cost of removal on the right hand side of 5 is 1. So the total cost will be 5 plus 1, 6. So if we perform the operations on this index, it will cost us 6. Now we will move to the next index, which is 6. If we try to make the permutation of length 6, then and also we will increment the our current will by 1. Okay, so if we try to make a permutation of length 6, then what we will do, we have to insert 6 minus 5 means one number on the left hand side. Fine. So 1 into insertion cost 5. So one number should be inserted. As you can see, 4 should be inserted on the left hand side to make a permutation 1 2 3 4 5 6, and on the right hand side nothing is there to be deleted, so the deletion cost is 0. So the total cost if we perform the operation on index 6 is, sorry, index 5 is, total cost 5 plus 0 is 5. So out of all these costs, what is the minimum cost which we are getting? 2. As you can see that if we make a permutation of length 3, then it will cost us 2 because the cost of removal is 2. So if we delete the elements 5 and 6, it will cost us 2 and we will make a permutation of 3. So yeah, this was all about this problem, guys. This was very easy problem. Let me show you the code. So yeah, this is the code, this part. I have maintained a current variable and I have iterated over my array, unique array. I have kept the unique elements in my uni array. Fine. And then answer equals to minimum of answer and I minus current into d. This is the insertion cost as I have explained you, and this is the deletion cost. Fine. So out of all these costs, we will maintain the minimum of all the costs and print the answer. So yeah guys, this was all about this problem. Thank you guys for watching the video.